Hi everyone. So, correct me if I'm wrong, but I believe before Easter break we had already looked at the chain rule, product rule, and the quotient rule. So I don't think we need to do them too in depth, but I just wanted to kind of do a little recap, just in case any of you have forgotten, to make sure you know how to use them. And then we can move on to the trig functions, which I don't think we have learnt how to differentiate yet. So I'm just going to do a basic example for each. First of all, we've got the chain rule here. Now luckily, because now you're doing everything as coursework, you don't now need to remember this. So all of these formulas you'll be able to look up, and any of your standard integrals you'll be able to look up, so you don't need to remember the derivatives for every single little thing all the time. Here I've got a function, y equals ln of sine x, so I can think of this as being y equals ln of some function that I can call u. You have the formula here if you want to use it, but you can just kind of remember how to do it. So first of all, I'm going to look at what is the derivative of my ln function. Well, if I'm trying to differentiate ln of u, then I can say dy by dx. The standard derivative for ln is going to be 1 over my function. So this is going to be 1 over sine of x. And then now I need to multiply by the derivative of this thing here. And so the derivative of sine x is cosine x. Like so. And now I can write this as cosine over sine, or if you prefer, hopefully remember that cosine over sine is the same as cot of x. And so I find my derivative using the chain rule. Let's move on to product rule. So again, you won't need to remember this formula because you'll have access to anything that you need to do for your coursework. It's on page 241 in the textbook, and the formula is that the derivative, if I've got a function of being a product of two different functions, then my derivative is going to be this thing just written as it is, and then the derivative of this function here, v, plus v just as it is, and then the derivative of my u function. So here we've got an example. I've just whipped this out of the textbook somewhere. Y equals e to the x and times sine x. So my derivative, dy by dx, is, and so now I can leave this thing just as it is. This is e to the x. And then the derivative of sine x is cosine of x plus, and then now let's leave the sine x just as it is, because that's my v function, multiplied by the derivative of e to the x, and the derivative of e to the x is just e to the x still. If I wanted to here, I could factorise out e to the x, because I can see that's a common factor of both terms. So I can write this as e to the x sine x plus cos x. And we are done. Next one, quotient rule. So when we use the quotient rule is when we've got my function here, instead of being as u times v, is u divided by v here. And then this is the rule. Again, you don't need to remember it now. If I wanted to differentiate this as an example, then I've got dy by dx is equal to, so I start off here with the thing that is on my denominator, just stays as it is, and I don't differentiate. So here I've got cosine x, so I'm just going to write that out, cosine of x. And then I need to multiply here by the derivative of my numerator, and the derivative of e to the 4x is going to be 4, let's just write that at the front, e to the 4x, like so. And then I'm going to subtract. My numerator just stays as it is, so this is just going to be e to the 4x. And then this time now I need to differentiate my denominator here. So the derivative of cosine x is going to be negative sine x. So because the derivative of cosine x is minus sine x, it means that this minus here will become a plus. And then now I'm going to divide. And on the bottom, I've got my denominator squared. So here we're going to have the cosine x all squared. So cosine squared x. Again, I could now do a little bit of factorising if I wanted to. So I can see I've got a common factor here, e to the 4x. So I could say that this was e to the 4x, and then I've got 4 cos x plus sine x all over cosine squared x. As I said, I believe we went through all those rules before half term, but if you need some more examples, then let me know. I'm happy to put up some more, and then I'll give you some questions to do as a refresher, and then we can go on to the trig stuff. Thank you very much, everyone.